This agent has been stuck in the same loop for 9 minutes, burning tokens, going nowhere. And the prompt behind it is perfect. I wrote it, it's good. That's the whole problem. Prompting is one layer of 3, and it's the layer everyone stops at. Prompt, context, harness. 3 words you've probably seen and never had cleanly separated. Here's the clean version. Prompt tunes the message. Context tunes the window. And the third one, harness, is the layer almost nobody is actually engineering yet, which is exactly why their agents break the way that one just did. That's the one I'm going to earn in this video. 2 layers first. This layer. So I'll be quick. Prompt engineering is the instruction itself. One message, one model, call, role, task, output format, couple of examples. And it works if your task is genuinely one turn. Classify this, rewrite that. A clean prompt is the entire answer. Don't build an agent for something a prompt already solves. The interesting part is where it stops. Look at what a prompt fundamentally can't touch. It can't give the model knowledge it doesn't already have. It can't remember what happened 3 turns ago. It can't call a tool, check its own work, or recover when it's wrong. The model only ever sees one window of text, and your prompt is just a slice of that window. So the moment your problem needs fresh information, memory, or more than one step, you haven't written a bad prompt. You've hit the ceiling of the wrong layer. Mid-2025, Andrej Karpathy made the case that context engineering is the better name for what we're actually doing. His framing. The real skill is filling the context window with just the right information for the next step, so the unit changes. Prompt engineering writes one instruction. Context engineering owns everything the model sees before it answers, and that turns out to be a much bigger, much more interesting problem. Because the window is not your prompt. It's the system prompt who the model is and its rules. Retrieved documents what it knows right now, usually through RAG, conversation history, tool definitions, and the results those tools just returned. Memory that carries across sessions. The user's actual message is a small slice of the whole thing. Context engineering is the discipline of assembling that stack, what goes in, what stays out, and in what order for every single call. Same model, better window, and the output changes completely. But here's the trap. More context is not better context. A team at Chroma benchmarked 18 models and named it context rot. As the window fills up, the model's ability to use any single fact in it drops. Anthropic's agent guidance is largely about designing around it. Why? Every token gets weighed against every other token. Stretch that across 100,000 tokens, and each one gets a thinner slice of the model's attention. That's not a metaphor, it's the architecture. And it fails in ways you'll recognize. Poisoning one hallucination gets in and keeps getting cited as if it were true and clash, where 2 parts of the window contradict each other and the model picks wrong. Watch a long session slowly lose the plot. That's not a dumb model. That's context rot. So the job flips from adding context to curating it. In production, that's RAG, to pull in only the chunks that matter instead of dumping the whole knowledge base. Compaction, summarizing old turns before the window overflows, keeping the decisions, dropping the noise. Structured memory, the agent writes durable notes to a file outside the window and reads them back when it needs them. Sub-agents that do focused work in their own clean context and hand back a 2-line summary, one concrete one. Instead of pasting a whole file into the window, a good coding agent keeps the path and reads the file only when it needs it. The target, in Anthropic's words, the smallest set of high-signal tokens that gets the outcome you want. And this is where most explanations of context engineering quietly stop. But notice the ceiling again. Everything we just did, the perfect window, is still one model call. Real products aren't one call. They're hundreds. In a loop, calling tools, holding state, recovering from errors, deciding when they're done. Engineering that, the thing that turns a good answer into a system that reliably acts, is the third layer. And this isn't fringe. In the very tweet that coined context engineering, Karpathy called it just one small piece of a thick layer of software that coordinates model calls into real apps, guardrails, evals, orchestration. That layer is the one nobody told you to build. Here's the cleanest equation in the field right now. An agent equals the model plus the harness. The model reasons, The harness is everything else, the scaffolding, that turns reasoning into action. LangChain and Databricks both frame it exactly this way, and once you see it, you can't unsee it. Prompt engineering lives inside the context. Context lives inside the harness. The prompt is the message. The context is the window. The harness is the whole system running around the model, and it is where the hard engineering now lives. So, what's actually in a harness? The loop first. Call the model, read what it wants, run the tool, feed the result back, decide whether to stop. Then the parts around the loop and Databricks, Anthropic, and LangChain all converge on roughly the same list. Tools increasingly standardized through MCP, the Model Context Protocol, a sandbox to run code safely, a file system for state that survives between sessions, automated memory management, the compaction and retrieval from before but built in, guardrails, permissions, policies, a human in the loop for anything dangerous, and observability, logging, tracing, evals. So when a run fails, you can actually see why. And here's the part that makes it a real engineering discipline, not just plumbing. Martin Fowler frames a harness as two kinds of control. Guides steer the agent before it acts the system prompt, the tools you expose, the instructions. Sensors catch it after tests, linters, type checkers, or a second model reviewing the output. Some are deterministic, a test passes or it doesn't. Some are inferential, a model judging quality. And your job stops being fix the answer and becomes steer the loop. When the agent makes the same mistake twice, you don't patch the output, you add a guide or a sensor, so it can't make that mistake again. Why is everyone suddenly talking about this? Because as the frontier models converge in raw capability, the model stops being the thing that differentiates you, the harness does. Databricks put a hard number on it. On their Office QA benchmark, the same model went from 36% to 53% just by upgrading the harness around it. 17 points, same weights. That's the gap between a demo and something you'd put in front of a paying customer. A strong harness around a mid model routinely beats a weak harness around a better one. Reliability isn't in the weights. But now look at that number again. 53% is still a coin flip you'd lose half the time. Because a great harness wrapped around a rotting context is just a very reliable way to be wrong. The loop runs clean, the sensors go green, and the answer is still garbage. This is the part people miss when they hear harness. The layers don't rescue each other. Get the prompt, the context, or the harness wrong, and the other two can't save you. That's why it's additive, not a ladder where the top rung wins. And you use all three every day, whether you name them or not. ChatGPT and Claude in the browser heavy on prompt and context. A system prompt, your history, memory, retrieval. Claude Code and Cursor are harnesses. You can literally watch work and agent loop over your code base. Tools reading and editing files. And a context window big enough to hold a small project, which only matters if you manage it well. Copilot's agent mode, same shape in the IDE. OpenAI's deep research is a harness built for one job plan. Search, read, synthesize, over dozens of steps. Enterprise RAG is context engineering shipped as a product, and every multi-agent system is pure harness orchestration, clean sub-agent context, shared memory. So hold the whole thing as one picture. 3 rings: message, window, system. Every failure you will ever debug lives in exactly one of them. Because the balance is what actually changes job to job. A simple, frequently asked questions, chatbot mostly prompt. A little context. Do not build an agent for it. An HR assistant, context dominant. The answer lives in your policy documents, so retrieval and permissions are the entire game. A coding assistant, harness dominant. It's a loop over tools with tests as the sensors. The prompt is the least of it. A customer support agent, all three. Intention. Prompt for tone, context for the customer's account, harness to actually issue the refund with a human check. And an AI research assistant harness for the multi-step plan, context to manage everything it reads without routing. Same 3 layers, completely different centers of gravity. Now the failures and almost every "the model is dumb" complaint is really one of these. People try to prompt their way out of a context problem adding, "please remember" to a model that has no memory. They dump the entire knowledge base into the window and wonder why quality tanks self-inflicted context rot. They ship an agent loop with no sensors, no tests, no evals, no tracing, so when it fails in production, they're completely blind. And the big one, underneath all of them, no evaluation at all. If you can't measure a run, you can't engineer any of these layers, you're just vibing. Remember that agent from the start? 9 minutes, stuck in a loop. The prompt was perfect, but it had no sensors, no evals, nothing watching it. So it couldn't tell it was failing, and neither could I. Wrong layer the whole time. And that's the tell. None of this shows up in the demo, it shows up later. In production, under load at 2a.m. Which is why so many good engineers still think the prompt was the whole job. This is also precisely what senior AI interviews are testing now, usually without saying so. Junior signal is I can write a good prompt. Senior signal is I can tell you which of the 3 layers a failure lives in and design the system so it doesn't. So when you get design an AI assistant for X, if you only talk prompts, you just capped your own level. The strong answer scopes the context retrieval, memory, the token budget, and designs the harness, the loop, the tools, the guardrails, and how you'd evaluate it. Say agent equals model plus harness, name how you'd measure it, and you sound like someone who's shipped one. And the direction is consistent. The differentiator keeps moving outward. Prompting got commoditized by better models. Context engineering is becoming standard infrastructure, and harness engineering, MCP, evals, multi-agent orchestration is where the frontier and the hard problems are right now. So, the whole video in 3 lines. Prompt engineering tunes the message, the instruction. Context engineering tunes the window, everything the model sees. Harness engineering tunes the system, the loop, the tools, the memory, and guardrails that make an agent reliable. They're layers, not rivals. Agent equals model plus harness. And the senior move is simple. For any failure, know exactly which ring to fix. Next video, I actually build the harness, the loop, the sensors, the evals on a real agent, and I show you every single place it breaks. That's the one that makes this one useful. It's on screen now. Follow if you want AI engineering the way seniors actually think about it.